but we're going to focus right now on one of the sidebars, okay? And the sidebar is where we put the bearing holes, okay? So how do we figure out our bearing holes? Well, first of all, we're going to sketch on this side, okay? So I just created a sketch, and we're going to put our bearing hole. There's going to be one kind of in the center, and it's got to be right on that center. So notice I highlighted and then I come down. Now, a 6-wheel drop means it is not going to be exactly in the center. Do not make your circle exactly in the very, very center of the bar. That's bad. We're doing a 6-wheel drop, which means this one is actually a little bit below that. Now, what I'm going to do is I'm just going to draw a circle here. Doesn't matter how big. I mean, I want to keep it inside, but that's about it, okay? My constraint is that it's right in the center of the bar this way, but not horizontally, just vertically, okay? All right, so actually I may have said that the wrong way, but you get the idea. You're just centered in this spot on the bar, okay? Then we are going to do one out here that is centered along the horizontal, right? Okay, so now I've got my 3 bearing holes. Well, how big are these? Okay, so here's how I would do constraints, by the way. Our bearing holes are 1. Okay, so this is dimensioning up here. Notice how it says D right after dimensioning. The way I did that down here is I just hit the letter D so that it flipped to D without going up here and clicking it. You can hover over each one of these and they give you their keyboard equivalent. So B is the keyboard equivalent for parallel. C is for circle, L is for line. You start to develop these after a while after you learn it. So I just hit D, go over here, dimension it. It's 1.125, okay? Actually, what I want to do is I'm going to do this for Control Z is your friend, by the way. I just undid that. I'm going to dimension the center one because I like having this one as my main one, okay? 1.125, okay? Now, all right, and these two both have to be the same size. So we're going to hit this equals button. This is a constraint force. It's also the E key. You click on this one because it has already been determined what the dimension is, and then you click this one. Notice it changed in size. I'll do that again to the left. I click this one, and I click this over here. Now they're all exactly 1.125, okay? Now if I change this one to 0.25, they all change to 0.25, right? I'm gonna undo that and go back to 1.25, 1.125. Okay. All right, so now we've got our 3 circles. Now, how far apart do these need to be? Okay, so here's what I'm gonna do. I'm gonna dimension this right now between this and this, just to give me an idea. And by the way, I do not want, okay, so notice this. Look at how this is going between the 2 dots. And it's measuring, it's not actually measuring the diagonal. I want the diagonal, which is right here. So notice the diagonal is 11.888, whatever, okay? And I can change that to just 11 inches, okay? Or whatever. But that's the diagonal. That's what I actually want here. I do not want, hold on. All right. I do not want to dimension this and have it be this, okay? Hopefully you can see the difference there. What is happening here is it's doing just the dimension from one dot to the other on the parallel, right? Or on the horizontal. It's not doing it on the diagonal, okay? And we need it to be on the diagonal. So if you picture a right triangle here coming down and then over, and then the diagonal, the hypotenuse going up. This is the hypotenuse, which is the 11.5, and this 11 point whatever is the bottom of that right triangle. Well, we don't want that. That's not how we're actually going to measure this, okay? So I'm going to get rid of that. The other thing here is I'm going to make this flexible in a second. So give me just a second here. I'm going to move this up slightly, by the way. Okay. All right. One other thing, I want to position the center hole perfectly so that it is locked in. Let's see if I can do that. Okay, perfect. Okay, that's what I wanted. Okay, notice my two yellow lines just came together there. What I'm doing is I'm placing a point right here, okay? That is my point, which is the absolute center of the bar, okay? Both on the horizontal and vertical, okay? I need this to drop down 3/16 of an inch or 0.1875. So I'm going to dimension that from the center here down to here is 0.1875. Okay. So now I have locked that in and it turned black. Okay. Because I've locked all the dimensions in and all the constraints are holding it in one location. All right. So that's perfect. I've got the right size. I've got the distance here, but I don't know that that distance is correct yet. Okay. Let me also go over here a little bit and dimension this from here to here. And again, I want that diagonal. I'm going to put 11.5. All right. Now we're going to figure out what we actually need. Okay. 11.5 inches. This is, let me put this into the chat. Okay. This is where we determine how to actually do this. And I'll show you exactly how to use this sprocket calculator, okay? The chain, we're gonna go down here first because we have no idea how many links, I'm sorry, we have no idea what the distance is. No, we don't have any idea what the links are. We're gonna do this bottom one first. Okay, so our chain pitch, how do we know these things? Well, we go over here, and this is the Andy Mark website. We use a number 35 strand, single strand chain. Okay, we can buy it in 10-foot lengths. We can buy it in different places actually. This one here, it tells you right here we're at a 3/8 inch pitch. Okay, so it's got the information we need right here, right where we order the chain. We go back over here to our calculator. 0.375 is our pitch. Okay. Now I'm going to say we're going to use the 15 sprocket tooth. Now we may use something different, but we're going to say 15 for now. How do I determine that? Andy Mark website, go right under mechanical again, and we can go to sprockets this time. So it's right over under here. You just go to mechanical and then chain and mechanical and sprockets. You know it's a number 35. You choose one and then the other. Okay. So sprockets, we can choose like a 15 tooth if we're using a number 35, right? These are 25, so don't choose any of these, okay? And you can also see they've got other options here, I think, for 35s. Yeah, like here they've got one that's a 22. Make sure that it's the right thing. Here's not hex shaft in the center. So you really need to make sure it's got the right thing on it to start with. So we're going to do the 35 and we're going to do the 15 tooth. And so we go back over to our calculator. We've got a 15 tooth. Now, drive and driven means the drive is where the gearbox is attached to. So the gearbox is on the other side of the sprocket. Then the driven one is the one out to the end. So going back to our diagram, this is the driven one. And this is the, or these are the driven ones. This is the driving one. This is the driving one right here in the center is where a gearbox typically goes. So you can do something like have a 15 sprocket one here and a 20 sprocket one out here if you wanted to, and actually change, oopsie, how you're doing it. So you can drive it with a 15 and have a 20 on the ends if you wanted to, okay? We're just gonna say it's 15 and 15. Typically we use the same sprocket, if I recall correctly, on all of them, on all three shafts, okay? So then our center distance, we're gonna guess at 11.25, and we're gonna compute. This gives us the approximate number of links, okay? Let's go back to our diagram one more time. So we chose actually 11.5 here. Let's do this. We also need to make sure we have enough room for our wheel. So we're gonna go from there to there, and I want it to tell me what that is. Now notice it's grayed out. This means that it is a driven dimension. It is not a driving dimension, okay? We're using this term driving and driven again quite a bit. That means that the 11.5 over here is really controlling the placement for this hole, and the 2.252 is just a result of that. It's just saying, hey, that's the amount of room you have left. It is a driven dimension. This over here is a driving dimension. So if I click on this, it says change to driven. So if I change it to driven, it just changes it to gray now. Now nothing is driving where this is placed, and it turns to blue. I'm going to switch it back to a driving dimension. And that means that it drives and holds to it, and this one will flex depending on how this one changes. Okay, let's think about our wheel for a second. We got a 4-inch round wheel, split in half. We got 2 inches before we rub up against something on this side, right? Now our tube for a drivetrain comes right down here, so we need at least 2 inches. This only leaves us about 1/4 of an inch. And if you think, our wheels have 4-inch plus a little bit of, rubber around the outside and whatnot, that's probably cutting it pretty close. So maybe we want it a little bit less than that. So let's change this to 11.3, okay? Pulls it back a little bit, and we change this to 11.3. Now let's go over to our calculator. 11.3 is where we're at, 11.3, and now we compute. Ooh, we've got a partial number of links now. It's really hard to cut our links in half, so we can't do that. So we're going to have to round up or down. Let's go ahead and just round that down to 75, which is what I've actually already done up here. Okay, we put in our same pitch, our same teeth, our same links in chain. I pull from down here. So I pull 75 up here, and now it's telling me my center distance has to be 11.25. So I go over here, and that's going to be my final answer, 11.25. Okay? So now we've got our centers for this. Okay. What I also like doing here is just changing this to bearing holes. It makes it easier for me to remember what's going on. Then I'm going to extrude this, and when I extrude it, I'm actually going to remove it this time. And I like removing it up to face, not blindly, okay? Blindly is usually a bad idea. I choose to face, and I'm going to take it to the other side of the tube and click on that face, okay? Takes it through the tube. All right. So that should be our holes. Now let's go back to our drivetrain. Yay, it looks pretty good. We did that correctly. Our center is dropped down 3/16 of an inch. So it's going to pivot on that, which is great. It's exactly where we want our holes to be, okay? All right. We're gonna go back then to our sidebar. And the next thing we have to do is we have to have holes so that we can mount our gearbox, okay? Typically what I would tell you to do is go find the gearbox out on AndyMark or wherever we get the gearbox that year. And download the actual step file for it, import it, and make sure all the holes line up, okay? Now, I happen to know that the one that we did, it was last year, the year before, was 4.5 inches across. So what I'm going to do is I'm just going to go in here, go right on this one again. What I want to do, it's going to be 4.5 inches across, or yeah, 4.5 inches across here, and then we're going to put our 2 holes. I'm going to put a dot right there in the center of it, just as a starting point. Now I'm going to do my circle. I'm going to come out from it, okay? This sets up my constraints, so it has to be in the center of this. Now, if I change where this hole is, say I decide my drop does not need to be 3/16 of an inch down, but I change it to 1/8 of an inch down instead, this will automatically shift up for me. This is why I use constraints as much as I possibly can when doing these things, okay? All right. So, and now I know that from here to here, because it's 4.5 inches total, has to be 2.25 inches. Okay, and from here to here. Now there's a way to do this with constraints, but I'll be honest with you, there's a trade-off between constraints and just entering the value twice, okay? Sometimes it's just easier to enter the value twice than it is to set up more constraints and things like that, okay? The other thing is I know that the hole size, and you have to figure this out, from your gearbox, hold on a second, is 0.196. 0.196, okay? I know both these holes have to be the same size, so I'm going to use my constraint again, hit equals, hit my first one, my second one, and now it's fully constrained and it is black. So I know when it turns black, it's fully constrained and we're set. Now, these are the holes that my gearbox can actually be mounted onto. I'm going to go up here, gearbox, holes, and we're good. Now I need to extrude that again by removing it. Just remove, and we're going to go to up to face. Again, I'm going to rotate this, and I'm going to go to the face on the other side, and my holes show up. Okay. I know some of this, by the way, I know some of this might be because you get so used to doing this. Like when I hold down the control key and then the right hand button, I move this around, and this is how you can move it around quickly. Or you can, if you have a scroll wheel and you have a button in it, if you click it and hold it down, you can move around fairly quickly. Okay. Just being able to get around a document quickly is sometimes challenging, and I get that. Play around with like moving things around and rotating stuff and figuring out how to, manipulate your drawing and view it from different angles. That's going to help you get around a lot faster for all of us. Okay. So we've got our sides. Let's go back to our main drivetrain for a second. We got our sides. By the way, when I label things, look at how nicely it shows up over here. Now I know where my front is, my back, my sidebars, and so on. When you label everything, it makes it much, much easier to find when you are on your assembly, okay? Much easier.